So this question is quite wordy. It's a typical question that's a combination of sequence and series and a savings account or an investment of some sort, something that you're making withdrawals from or you're making contributions to. So in this case, we've got Anita who's opening a savings account. She is depositing X amount into the savings account at the start of each month, and at the end of each month, after interest is added, the bank is withdrawing $2,500 from the savings account as a loan repayment. So we've got stuff going in and stuff coming out. And this here is the amount in the savings account after the nth withdrawal. Okay, and they pay interest at 4.2% per annum, compounded monthly. Okay, so the first part of the question is saying, show that after the second withdrawal, the amount in the savings account is given as such. Okay, so this is where we just do it. We do it each iteration. So we start off at the end of the first month, and then we go to the second month. Okay, so let's think about what is in at the first month. Okay, so in the first month, we would have deposited X amount at the start of the month, and that will have undergone some compound interest for that month. Okay, so it'll be itself plus, so 1 plus the rate that it's gone up within 1 month. Okay, and that's the 4.2, but it's compounded monthly, so we've got to go 0.042. I'm just writing it as a decimal instead of a percentage, and then you're going to divide it by 12. Okay, and then you're going to minus off the bank withdrawal, which is the 2,500. So let's just simplify that a little bit. If we put this into our calculator, we're going to get 1.0035. Okay, and that's going to come in handy later when we use that rate again. All right, so let's move on to the second month. That's what the question wants. It wants how much is in the bank account after the second month. Okay, so what we're going to have is we're going to have the first month plus however much you're putting in at the start of the month, which is X, all multiplied by this rate, 1.0035 minus, again, the same, you take off 2,500 at the end of the month. Okay, so we're going to substitute in this M1 into here, and then we're going to expand it so it gets a bit nicer. So M1 is just X outside of 1.0035 minus 2,500 plus X, and then that's all multiplied by 1.0035. Okay, so let's expand that out. The first term is now got 2 of these, so we can write it as a square like that. The 2,500 only has 1. Don't forget the minus. And then this X only has 1 too. As you can probably start to see, there's going to be a pattern where we've got this geometric series going on. So this is the R, and this is the number, or however many iterations you've gone through. So let's just clean it up a bit, make it a little bit nicer. I'm going to put X on its own. I'm going to factorize out the X, so we're going to have a 1.0035 squared plus 1.0035, and you can see how that there is just a geometric series. And then we're going to take out the 2,500, which is that monthly repayment at the end of the month, and then you're going to see we have another geometric series, but it's going to be 1 behind, like that. Okay, all right, so that there is the answer for the first part of the question. So let's now move on to the second part of the question. So the second part of the question is find the value of X. So the amount in the savings account is 80,000. Okay, so we need to remember that number, 80,000, after the last withdrawal of the 4th year. Okay, so let's go down start that question off with a fresh page. So we need to have $80,000 in the account at the end of 4 years after the last repayment has been made. Okay, so now we've got to remember that's got to be in months because that's the units that we're using here. So 4 times 12 is 48 months. Okay, now we're going to have to find the formula that we can use to describe this when we've got like a lot higher numbers. It's not like we're going to go M1, M2, M3, M4. We need to be able to see that this is a geometric series and therefore we've got a formula for it. Okay, so I'm going to write it out in a generic format first, and then we can write it as a formula. So I'm going to say that 80,000, so the amount that's left, is going to be equal to X, which is my monthly contribution at the start of the month. And then I'm going to have one too many. Let's clean that up. I'm going to have 1.0035 to the 48, and that's going to go all the way down to 1.0035. So similar like we had for M2, but this is going to be for M48. And then we're going to take off my monthly repayments, which are going to start at 47 and go all the way down to 1. Okay. All right, so now we need to use our geometric series formulas for the sum of a geometric series, and just replace everything. So for the first one, we're going to have A, or whatever, so the amount out the front, and we're going to have the rate. So this is what the first term is over here. We put that out the front. We put this to however many iterations or periods we're going through, and that's all over 1 minus the geometric rate, so what's inside the bracket. So this is 1 minus this minus 1, sorry. So again over here, we're going to have 2,500 is the amount that we're multiplying everything by. I have 1.0035 to the 48. So very similar. Now this is a scenario where it's probably just worth chucking it all in the calculator. So I'm going to cheat a bit and skip ahead. You guys can remember that if you just stick this in the calculator, you should get the same numbers. So I'm going to move this bit here, all that bit there, onto one side. So write that out. So all of that should be equal to, if I put it in my calculator correctly, okay. So now if we're trying to, we can put this in our calculator too. So we get X times 52.351 is equal to 210421.205, and so on. So therefore, the monthly repayment that we need to make, or the monthly contribution we need to make, X, has to be, this is a monetary value, so we're going to put the symbol in there, $4,019.42, so that we end up at the end of 4 years with $80,000 in our bank account. So if we just want to quickly go back through that, I know this can be a bit confusing. If we look at part I, what we've done is we found the amount after 1 month. So that's where you've got X, which is your contribution, times the compounded interest on it, minus how much you take out at the end of the month. And then we move to the second month where we do the same thing again.
Snack is an online platform to instantly create and share videos just like this one. To watch more or try a hand at making your own, head over to snackapp.io.